Hello, dear students, friends. Very good morning. How was last class? Parking studies, in which lastly we have covered under parking study the different parking facilities: on street parking, off street parking. So every time in big cities, it may not be possible to allow the vehicles to park on street. Thereby, off-street parking is resorted by the government or municipality or corporation, and accordingly, the parking facility is created either in the form of surface car parking or multi-storied car parking or roof car parking, or even it can be provided mechanical car parking mechanical car parking as shown here, or underground car parking. This everybody must have seen, whereas mechanical surface car parking you must have seen, whereas multi-storied car parking might not have been observed or watched so far. If you go to big cities like Bombay, Pune, you will find that sort of parking facility also. Today, we will continue this with the highway lighting system. That is the last chapter or last article in traffic engineering. That is most essential during night time driving or during cloudy weather. Even in the morning, the street lights will be on, especially at intersections, at curves, at valley curves. Without lighting, it is not quite possible for the easy vehicular traffic movements. Highway lighting design procedure for transport lighting. What are the contents under this? Need for street lighting, definitions, distribution of light, design factors for street lighting. This is one type of very nicely looking. These are all being used in big cities. It is one of the arboriculture also. Means in order to enhance the beautiness of the roads, such type of good quality light arrangement is being done. Necessity of highway lighting. Necessity of highway or transport lighting. What are the necessities? We will see. The main purpose of street lighting is to enable the road users to see accurately and easily the carriageway and as well as the immediate surrounding in darkness. Majority of road accidents are caused in night, and the poor lighting is the main cause. So just because of less provision or less lighting system on highways, especially national highway, state highway, road accidents are becoming increased. Improved visibility at night by means of artificial lighting reduces the strain on driving and ensures comfort. The drivers feel more confident in driving under proper street lighting. With better lighting, the speed of traffic generally improves and traffic flow condition improves. Highway lighting is particularly more important at intersections, bridgeside, level crossings, and places where there is restriction of traffic movements. You carefully understand the concept of highway lighting. Every throughout the stretch of the road, it is not quite possible to provide. Where at least highway lighting is particularly more important at intersections, bridge side, level crossings, and places where there is restriction of traffic. traffic. Restriction of traffic movements. Highway lighting is very, very essential. On urban roads where the density of population is high, road lighting has other advantages like feeling of security and protection, especially when ladies are moving during the night time. Because of insufficient number of lighting system or insufficient lighting on highways, undue incidences may take place that can be prevented by providing good lighting system so that all human beings will feel security themselves and protection. Factors affecting night vision. Factors affecting night vision. You see how the lighting system is done here. Very nice, beautifully it looks. Of course, these are all photographs. But if you go to the big city, even at Kopargaon, during night time, those lights which look very beautiful. And everything is visible. So what are the factors affecting night visibility, night vision? Amount and distribution of light flux from the lamps, size of object, brightness of the object, brightness of the background, reflecting characteristics of the pavement surface, glare on the eyes of the driver, time available to see an object. These are all various factors affecting night vision. Amount and distribution of light flux from the lamps, size of the object, brightness of object, brightness of the background, reflecting characteristics of the pavement surface, glare on the eyes of the driver, time available to see an object. Important terms which you have to understand under this. Important terms which are luminous flux, symbolized by phi. This is the radiant power given by light source. In SI unit it is lumen, Lumen, not lemon. Lemon is limbo. This is lumen. Lumen. It is equal to the amount of flux received on surface area of 1 square meter of sphere when a light source of 1 candle power placed at its center. In SI unit, luminous flux. Lumen is equal to candle power into solid angle. Further, some important terms. Steradian. A steradian is unit of solid angle. Whatever we said in the previous slide, solid angle multiplied by candle power is equal to lumen. It is equal to the solid angle subtended at the center of sphere by unit area of its surface is known as steradian. Next, luminous intensity, I. Luminous flux emitted per unit solid angle is called luminous intensity. Candela, not Cinderella, Candela. It is the unit of luminous intensity. Luminous intensity expressed in candelas is called candle power. These are all very simple. You yourself can understand. Theoretical, dead theoretical. Further, glare. Condition of vision in which there is discomfort or a reduction in the ability to see significant objects or both due to an unsuitable distribution of luminaire or to extreme contrasts in space or time is known as glare. Lantern. Lantern, the symbol of Lalu Prasad Yadav's party. Lantern. A house for one or more lamps comprising a body and antirefractor, reflector, diffuser or enclosure associated with the lamps. Lastly, illumination E. It is the measure of the amount of light flux which falls on a surface. It can be calculated as using the formula ES is equal to LM multiplied by CU multiplied by LMF divided by S multiplied by W. Lux or lumens per meter squared is given as illumination E or ES. What are what in the above equation? We will see. LM, lamp lumens, LM, lamp lumens, Cu coefficient of utilization, LMF lamp maintenance factor, S spacing between the luminaries in meter, W is equal to width of the roadway or street in meter. Luminance or brightness. The luminous intensity or reflected per unit area of a surface is called luminous. The luminous intensity which is emitted or reflected per unit area of a surface is called luminous. Now, distribution of light, how the light is distributed. The total output of a point light source will naturally radiate uniformly from the point with equal intensity in all directions. It is evident that such light distribution would be insufficient and uneconomical when the purpose is to direct the light toward a relatively limited area such as the pavement or a street. So when there is relatively limited area, it becomes uneconomical when the purpose is to direct the light. In such case, it is evident that light distribution would be insufficient. Okay, there are mainly three types of distribution of light, like glare, first one glare, second one vertical distribution of light, lastly lateral distribution of light. These are the three types of distribution of light. Glare. The disturbing influence when viewing a difficult visual task under low brightness conditions is known as glare. Once again, I would like to say this. What is glare? The disturbing influence when viewing a difficult visual task under low brightness condition is called as glare. There are two types of glare: disability glare, discomfort glare. So you can see here, when such lights are provided, there will be glare for the road users when they are driving the vehicles. That should be minimized or avoided so that glare should become nil. The amount of glare present is dependent on, it also depends on some factors: brightness of glare source, angle of incidence with respect to the normal line of vision, area of glare source, distance of glare source from the observer. These are the four important points to be noted down. The amount of glare present, which depends on lamps. The lamps commonly used for highway lighting are, as shown in these photographs, namely tungsten filament lamps, fluorescent lamps, sodium vapor lamps, mercury vapor lamps. These are all the different types of lamps commonly used for highway lighting. Luminaire distribution of light. To have the best utility of the luminaire or source of light, it is necessary to have proper distribution of light. It should be aimed to achieve following purposes. It should be aimed to achieve the following purposes. It should cover the pavement between the curbs. It should make prominent the traffic signs and other objects on road. It should produce maximum uniformity of pavement brightness. Horizontal aiming. The horizontal direction, the light. When two floodlights is mounted, mounted on a single pole, then horizontal aiming also must be considered. Each floodlight should be vertically aimed according to the 2/3 rule. The floodlight should be aimed up to 90 degrees apart. The distribution of light in the horizontal direction is equally important. Distribution of light in the horizontal direction is equally important. It is not enough that the pavement alone is lighted from aesthetic consideration. Don't think that lighting is done from the viewpoint of aesthetic consideration. The pedestrian footways and the curbs are also need to be adequately lighted. So we should not ignore the pedestrians and passengers. This is horizontal aiming. See, there are two floodlights, right? One is here, another one is here. It should throw light in such a way that maximum area should be lightened. For that, there is 90 degree here. It is 90 degree. In that case, if we provide like these two lamps at 90 degrees, it throws the light over a larger length or width in horizontal direction. There are three types of horizontal distribution. One, symmetrical distribution. You can see here, symmetrical in horizontal direction. From the center, it is symmetrical. Axial distribution, non-axial distribution. You see, in order to see that the light is thrown symmetrically over a larger width of the road and length of the road in horizontal direction, these are the various alternative arrangements of lights. So whenever you find free time, individually you click and zoom it and read on your own and understand. Vertical aiming. The vertical distribution of light in street light system follows one of the three types. Cutoff. In cutoff system, the light is reduced as completely and as rapidly as possible above 70-degree angle with the downward vertical, the main beam being usually at this angle. This system eliminates glare. Non-cutoff or high angle beam. Non-cutoff or high angle beam. In this case, the peak intensity is at about 80 degrees and there is considerable output near the horizontal plane. With this system, a certain amount of glare is inevitable, means it cannot be avoided in this system. Certain amount of glare is inevitable and the modern lighting practice does not favor this system. That means this system should not be adopted or used or implemented. Semi-cutoff or medium angle beam. This is the system in which the angle of beam system is in between above two systems with a peak intensity directed at an angle of 75 degrees. In the previous case, 70 degree. In the present case, that is middle case non-cutoff, it is 80 degree. Here it is 75. So in between, neither 80 nor 70. It is average if you think logically. 75 degrees, semi-cutoff, medium angle beam. This system with a peak intensity directed at an angle of 75 degrees. Design factors for lighting. Various factors to be considered in the design of street lighting are contrast, height and overhang of mounting. So whenever we are mounting lights, the overhang on either side, depending upon. Suppose if this is the road, suppose if we are putting electrical pole here, one electrical pole here, staggered fashion, only overhang will be towards the pavement. So from here, the overhang will be like this, overhang bulb, and overhang bulb is provided at suitable height so that the light will be thrown on overall larger area. The glare on eyes from the mounted lights decreases with increases in the height of mounting. Usually mounting height range from 6 to 10 meter. It depends. As the height increases, glare will reduce. It is indirectly proportional. Overhangs on the lighting poles would keep the poles away from the pavement edges, but still allow the lamp to be held above the curb bar towards the pavement. So that's why I have shown the lighting system, how it should be. The lamp should come above the pavement, but the pole will be away from the pavement. Height and overhang. The lighting pole should not be installed very close to the pavement edge, because in that case the capacity of the roadway is decreased and the free movement of traffic is obstructed. IRC has specified the following horizontal clearances for lighting poles. IRC has specified the following practice of dimensions. For roads with raised curbs, as in urban roads, minimum 0.3 meter and desirable 0.6 meter from the edge of the raised curb. For roads without raised curbs, minimum 1.5 meter from the edge of the carriageway, subjected to minimum 5 meter from the center line of the carriageway. These are all different patterns of providing light, that is layout of or plan of lighting system. This is if you consider that this is the road, then lighting should be done on one side itself, or it can be staggered. Especially at intersections, the spacing between the two lamps will be smaller than on straight stretch. Whereas on a horizontal curves also, if it is a sharp curve, the interval or spacing between the two light poles will be smaller than for a gentle curve. So when the vehicle is placed on the road, suppose if this is the mounting height and this is the cantilever portion where the lamp is fixed, then when the light throws, it depending upon the width of the vehicle and height of the vehicle, how much light it throws, you can see. This is the portion of shadow, this is come under shadow. Here this much portion will come under shadow. If this is the height at which the lamp is provided without cantilever, then whole area will be under shadow. So that is the reason why that is required to be properly designed. This is the desirable. This is the desirable. Okay, mounting height is also being specified by IRC. Mounting height should be 1/2 the distance across the area to be lighted. If the area to be lighted is 16 meter, the lowest recommended mounting height is 8 meter. Mounting height is equal to half the distance to be lighted. Therefore, half of 16 meter is equal to 8 meter. Okay. This is how mounting height is calculated. 8 meter mounting height. Then the light will be thrown properly. Spacing of lighting units. Spacing. IRC have specified the spacing between lamps on straight road is about 3 to 5 times the mounting height. For sharp curves, the spacing between lamp is closer for better visibility conditions. I have already told you on sharp curves, the spacing between the two lamps is closer or smaller than on gentle curve or on straight roads. However, the spacing between the lamps on straight road is about 3 to 5 times the mounting height. So mounting height is 8 meter means 24 to 40 meter. 24 to 40 meter is the spacing between lamps provided on straight stretch. Okay, further spacing. When more than one luminaire per pole is required, then the distance between the two adjacent luminaire or pole is 4 times mounting height of the luminaire pole. Similarly, all these values have been given. You yourself can go through and understand slowly or gradually after the class is over. You see, coefficient of utilization. So anyway, we may not be able to complete in today's class. Last class on this unit 3, we will continue this highway lighting end with formula along with the coefficient of utilization, etc. in the next class. Okay, thank you for hearing. Have a nice day. We will continue in the next class.